WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Hello viewers, welcome to Eko Learners Support for WAEC and NECO candidates. I'll be your physics instructor for this class. Follow me as I take you through projectiles.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Like I said, we are looking at the topic projectiles. Under this part of projectiles, we'll be looking at the meaning of projectiles. We'll also look at examples of projectiles. From there, we'll check through applications where projectile is made use of. Then we'll now look at some technical terms that is associated with projectiles. But in this class, there is something I'm expecting from you. It is that at the end of this lesson and in the course of the lesson, you should be able to define projectiles. You should also be able to highlight different examples of projectile motion. More so, you should be able to describe and explain some technical words that we make use of in projectiles. Now, projectile. A projectile motion is one that follows a curved or parabolic path, but that motion is under the influence of gravity. And the path which that object follows is what we call trajectory. So if you remember an athlete, if an athlete is to run, it will follow a path called lane. So if an object is to perform a projectile motion, it will follow a path called trajectory. So that's the meaning of that word. Now, look at this. For projectile motion, if an object is undergoing a projectile motion, now this is how it's going to look like. You can see this blue part and this yellow part. The object takes off from rest and goes into the air, under the influence of gravity, goes and comes down. So it's following a parabolic path. That's the trajectory. Now for it to move and go up, it requires a velocity u, initial velocity. Then while projectile motion is taking place, we have an upward movement and an onward movement. There's an upward movement, there's an onward movement. So which means that two distances are covered in one motion. That is projectile. Both the vertical distance and the horizontal distance. So the vertical distance is what we represent as maximum height. And the horizontal distance is what we call range. Don't worry, you get to see and understand what I'm talking about in detail soon. So this angle of inclination to the horizontal is what we call theta. That is the angle to which you project that object. So if you have an object this way, let's assume to the horizontal, you can project at angle 30 degrees. The same object you can project at angle 49 degrees. So you will see in this class the effect of these differing angles. What effect it will have on what we are talking about on projectiles. So, but then I want you to know something as we go. Look at this. There are some objects that undergo projectile motion. Have you seen a lawn tennis player before, the likes of Roger Federer, Rafael Nadal, Petra Sampras, those guys, they play lawn tennis. The ball leaves the ground, goes beyond a net and comes down. That is a projectile motion. If you have seen a free kick taker before during football matches, Ronaldo, Ronaldinho, Okocha, and the like, when they play free kick, they play the ball from the ground, it takes off across the walls and it comes down. So that object, that ball has performed a vertical motion and also a horizontal motion. Then a projectile has taken place. Not only that, if you have seen a high jumper, when he wants to jump, he wants to move his body across a bar, it goes up and moves forward. So there's an upward movement, there's an onward movement. It's a projectile motion. If you want to hunt bird, I remember those days in the village. You are going to farm, you have stone in your pocket, you shoot the stone from your catapult to the bird. So when you shoot the stone goes up and moves forward. So there's an upward movement and an onward movement. That is a projectile motion. Aside that, when you fire bullet from a gun, this is gun. That's also an example of a projectile motion. So a cricket ball thrown against the wall. You remember those days, if you are in school, you are playing with your table tennis ball, you hold your bat, you hit it to the wall, it goes and comes back. That is also a projectile motion. Now, let's look at this projectile motion we're talking about. Where do we make use of it? We make use of projectile motion in warfare, in sport, and in all our day-to-day activity, day-to-day life, day-to-day activity. As you are going on the road, you decide to jump a staircase downward. For you to jump, you must have moved forward and then go down. So there's an onward movement and an upward movement. So it's a projectile motion. If you want to jump a gutter, by the time you pick yourself and you jump, you go up and you go forward, it's a projectile movement. That almost your day-to-day activities, you perform projectile motion. If you want to enter the vehicle and you are jumping down from the vehicle, you are performing a projectile motion. Your friend, you are going on the way, your friend say, give me something, maybe in the class, you throw it to him, it's a projectile motion. Now, that is for day-to-day activities. Now, in warfare, if you want to shoot gun, javelin, whatever, you want to throw it into the air, it's performing a projectile motion. Sports, football, lawn tennis, table tennis, long jump, high jump, all of these, they make use of projectile motion. Now, let's talk about the terms associated with projectile. When we talk about projectile, what are the technical terms? When you hear it, you know we're talking about projectiles. Let's start from the word time of flight. When we talk about time of flight, what comes to your mind? Possibly you will have heard over the radio that the time of flight from Lagos to Abuja is 45 minutes. What does that mean? It doesn't mean that you leave your house and get to where you are going to in Abuja 45 minutes. No. It means the time is going to take you to leave the ground in Lagos and touch the ground in Abuja. That is what we call time of flight. So time of flight is the time taken to leave the horizontal ground and return to the same horizontal level. That's what we call time of flight. So we complete the journey before we say this is time of flight. So in that case, you move from the starting point. There's a place where you have the highest vertical displacement. We're still going to talk about it. That is called the maximum height. For the sake of this formula, I want to expatiate a bit so that you will not forget and you don't need to cram. So from here, as you are starting, you need a velocity to cause the motion to start. As the motion starts, we have this velocity now will now be splitted into two. We have the one responsible for the upward movement, that is uy. And we have the one responsible for the onward movement, that is ux. So in this place now, you can make use of trigonometry. by saying this way, you're going to have ux, and this is u, and this is uy. So when you do this, from trigonometry ratio, you have sine theta equals to opposite uy over hypotenuse u. When you make uy the other formula, you're going to have uy equals to u sine theta. So which means that it's not all the velocity that you are projecting with that is responsible for the upward movement. Part of it also is responsible for the forward movement. So for the upward movement, you make use of uy, which is u sine theta. So if you are now considering a journey that is forward, onward, you are going to make use of ux, and that is cos. If you look at cos theta, that is adjacent ux over hypotenuse u. When you cross multiply, ux equals to u cos theta. So when you are looking at the journey horizontally, the velocity component you are going to use is u cos theta. For the upward movement, the velocity component you make use of is going to be u sine theta. Now, how did we arrive at this? For a journey that is going upward, it is against gravity. So our acceleration is given against gravity. That's the meaning of this minus, against gravity. Then the velocity responsible for this movement is going upward. Once it is going upward, that is y, uy. So our velocity now will be given as uy, the u. That's uy, which is u sine theta. At maximum height, velocity is 0. How? You try, throw a ball into the air. You see that as the ball goes up, when it gets to the highest point, it's as if it's going to rest for a microsecond before it comes down. Once it stops, it has to stop moving upward before coming down. So once it stops moving at that maximum height, once it stops, velocity is 0. It starts dropping. So at that final destination up, velocity is 0. So from here, if you want to calculate the time of flight, you must know the time it's going to take to get to the maximum height. Because the time it's going to take to get to the maximum height is still the same time it's going to take to drop down. So which means, let's look for the time it's going to take to get to the maximum height. We multiply it by 2. So we look at it. Which equation of motion we make? We have v, we have t, we have u, and we also have a. So that is v equals to u plus at. So from here now, v, remember that I said that at maximum height, v is 0. Then the u responsible for the upward movement is uy. This is going to be u sine theta. The movement is going up against gravity. That is going to be minus g. And then t. So from here, we are going to have, bringing this gt to this side, you are going to have gt equals to u sine theta. When you now go further and make g the subject and make t the formula, you're going to have t equals to u sine theta over g. So that is what we are having here. This is time taken to reach maximum height. The same time it's going to take to reach maximum height, the same time it's going to take to come down. So time of flight is go up and come down. Once you know the time to go up is the same as time to go up to come down, then time to come down will now be 2 times time to go up. So that's going to give us 2 times u sine theta over g. This gives us 2u sine theta over g. So that's how we arrive at this formula. So the next part now, look at this, the maximum height. The maximum height talks about the highest vertical displacement from the point of projection, from the horizontal point. So if you have it this way, and you have your maximum height this way, this is going to be your maximum height. So how do you arrive at this formula? Look at this. Once, for you to get to maximum height, it's going up. So your movement is against gravity. And at that maximum height, the object needs to stop, it rests, then start coming down. Then our final velocity is 0. For it to go up, the velocity responsible for that is uy, which is u sine theta. And in this case, the distance covered is the height that we're talking about. So which equation of motion will make use of all these parameters? Let's make use of v squared equals to u squared plus 2as. At maximum height, v is 0. So this is 0 squared equals to u sine theta all squared plus 2 times the journey is against gravity, minus g, and the distance we're looking at is the height. So in this case, you're going to have 0 equals to u square sine square theta. So what I mean in this place is this. When you have u sine theta all squared, it means u sine theta times u sine theta. So u times u square, then sine theta times sine theta. In mathematics, you write it as sine square theta, or you write it as sine theta all squared. So in this case, so that this will give us u sine square theta plus times minus will give you minus. So 2 times g is 2g, and h, that will be 2gh. When you bring 2gh to this part, that will be 2gh equals to u square sine square theta. So making h the formula, you're going to have it this way. So h becomes u square sine square theta over 2g. So this is how to arrive at it. So if you understand it this way, you don't need to cram. All you just need to know is to understand the concept behind it. Terms associated with the last part, which is the range. The range is telling us about the horizontal distance. So in this case now, please, I want you to listen very carefully. The journey is this way. And then the object is moving this part, this way. So if it's going this way now, this way, the horizontal part is what we are looking at for range. And the velocity responsible for that is what we call the ux, the horizontal component. And that is defined as u cos theta. Now, let's look at other parameters. Our acceleration here is 0. The velocity responsible for the journey is the horizontal component, which is u cos theta. The distance we are considering is what we are labeling as range. And then the time taken, please take note, the time taken to complete a range is always the time of flight, because it must have gone up and come down. So for us to have a range, so that time taken is not the time to reach maximum height. You might see it written in small letter. It's not the small letter, it's actually the capital letter, because it is the time of flight. For it to cover a horizontal distance, it must have gone up and come down. So in that case, the equation of motion that's going to house this is going to be s equals to ut plus half at squared. Knowing fully well that a is 0, everything a will multiply becomes 0. So every part of this equation becomes 0. Then we're going to have s equals to ut. In this case, s is our range. U, the one responsible for the horizontal movement, is u cos theta. So this is going to be u cos theta. Then t, I told you, it is the time of flight, that is t. So from here, we know that r equals to u cos theta times the value of t we just did here. From here, look at this. Let me show you again. The time of flight is 2u sine theta over g. So we go there now. So times 2u sine theta over g. So from here, you're going to have it as u times u square times 2 sine theta cos theta over g. From mathematics, 2 sine theta cos theta will give us sine 2 theta. So you're going to have r will be equal to u square sine 2 theta over g. So that's how we arrive at this. Now, there's what we call maximum range. Maximum range is talking about the longest horizontal distance. Let's take, for instance, if you see those who have, if you have ever watched football, you will see that there are sometimes keeper will kick the ball and you get to the middle of the field. But there are sometimes keeper will kick the ball, it will be from keeper to keeper. So at that time, it has covered the longest horizontal distance that is obtainable. That is called the maximum range. So in that case, how do we achieve that? There's a particular angle. Now, look at this. If you have the same velocity and you have the same acceleration to gravity, the only factor that can determine that is the value of your theta. Like I told you that time, you see the impact of theta now. So for you to get the highest value of range, What is the highest value you can get for sine of any angle? That is 1. So it means sine of any of that angle must give you what? 1. So which means that 2 theta equals to arc sine of 1. So 2 theta equals to 90. So theta equals to 90 over 2, which is what? 45. Watch out. Your JAMB, WAEC or NECO can give it to you as an objective question. At what angle will you have the maximum range? This is what you have just seen. That is at angle 45. So once you want to have highest range, just shoot your ball. If you're a goalkeeper, or you want to project a missile, possibly, you want to project a missile, just direct it at angle 45. It will travel the farthest for the same u, this initial velocity, and for the same acceleration due to gravity. So I'm sure now you understand how we arrive at range and how we arrive at maximum value of the range. You don't need to cram. All you just need to simply understand and digest it. Before you know it, you are good to go. So it's time for us to play with some things. Yes, from what we have learned, we need to play. Let's look at what we want to play with. What is projectile motion? Mention 2 applications of projectile motion. Highlight 2 examples of projectiles. Define A, time of flight and maximum height. I'll give you just 1 minute to go through it. All right, now that you have gone through it, what is projectile motion? It is the motion of an object moving in a parabolic path under the influence of what? Gravity. Number 2, application of projectile motion. Where do you apply projectile motion? You can apply it in sports where you kick football. You can apply it in warfare where you launch missiles. Aside that, 2 examples of projectile. Please, I want you to take note of this part of the question. 2 examples of projectile. Some of you will say, simple now, ball. It's not ball. It's a kicked ball. Don't tell me javelin. It's a thrown javelin. If you don't put it that way, you are wrong. It must be put accordingly, written accordingly. It is a kicked ball. A ball can be, if you just say a ball can be on the ground now. You have forgotten that you can kick ball at time and it will be straight on the ground, just be rolling on the ground. That is not a projectile motion. So if you kick it into air, it must be kicked for even to perform any motion. So for your projectile, it must be, you must use those specific words. A stone shot from a catapult. Don't just say a stone. Don't just say a catapult. I can try to keep the stone in my pocket. That doesn't make it. That doesn't mean that projectile. It has performed a projectile motion. Please take note of those words. Now, time of flight. The time taken to start, to leave the horizontal point of projection and return back to the same level. And the distance between the horizontal part and the highest level attained is what we call the maximum height. With this, I want to believe you have learned something.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So if you have any question, observation, comment, or anything you want to interact with us with, you will see our social media handle rightly displayed on the screen. Kindly forward them to us. We're waiting to hear from you. Thank you.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.